Section 7, PTEC Course 203, Cost Approach to Value. Oh, no.
I told you.
I hate depreciation. Oh, God. 4 cost approach methods. Replacement cost new, less depreciation. Replacement cost new, less depreciation.
Slow down.
Reproduction cost new, less depreciation. Historical cost, trended historical cost. Major economic principles underlying the cost approach. Principle of substitution. Market value of a property tends to be set by the cost of acquiring a fully comparable substitute property, assuming no costly delay in acquisition. Therefore, replacement cost new, RCN, tends to set the upper limit of value. Principle of contribution. The value of any improvement to a property is measured by the amount it contributes to the property, not by the cost. Law of increasing decreasing returns. Increments of the agents of production will add greater value to the point when the market has no demand. Over improvement or oversupply, or the costs become prohibitive and the market will not bear the cost. Principle of anticipation. Value is created by what potential buyers expect as to future benefits. Steps to the cost approach. This isn't exactly depreciation, so maybe I reacted a little strongly. What are you doing?
I'm trying to get over here. This thing here.
Steps to the cost approach. Estimate the land site value as if vacant and available for development to its highest and best use. Estimate the total cost new of the improvements as of the appraisal date, including direct costs, indirect costs, and entrepreneurial profit from the market analysis. Estimate the total amount of depreciation attributable to physical deterioration, functional obsolescence, and external economic obsolescence. That's what I hate. Subtract the total amount of depreciation from the total cost new of the primary improvements to arrive at the depreciated cost of improvements. Estimate the total cost new of any accessory improvements and site improvements, then estimate and deduct all depreciation from the total cost new of these improvements. Add site value to the depreciated cost of the primary improvements, accessory improvements, and site improvements to arrive at a value indicated by the cost approach. Terms associated with the cost approach. 4321 rule. I was told I didn't have to read that because he done know it all. Breakdown method, a method that divides depreciation into all the various components for the building. Comparative unit method, a cost method used often in mass appraisal. Replacement cost new is based on square foot using cost and or approach schedules. Consistent use, the improvements on the site are the same as the highest and best use as the land. If the use is not consistent, the building is a burden on the land and has no value. Direct cost, the labor, materials, and profit to construct an improvement, the bricks and sticks. It's also called fixed or hard cost. Entrepreneurial profit, the amount above the actual cost to compensate the developer for the contribution to the project and associated risk. External incurable depreciation, loss of value to an improvement due to sources outside the subject property line. Examples: traffic congestion, water treatment plant, downwind of cattle feedlot, etc., always considered incurable. Fixed costs, costs that remain static such as labor, materials, and supplies, also called direct costs or hard costs. Fixtures, personal property that has been attached to the real estate in a way that removing the personal property would damage the real estate. It is required to use the real property, or if the intent of the owner was to make the personal property part of the real estate, the personal property is now part of the real estate. Forecasting, developing an opinion of value of land based on similar improved properties and and their total sales prices. Functional curable obsolescence is of the devil. It is economically feasible to cure. Functional incurable obsolescence is not economically feasible to cure. While it may be physically possible to cure the problem, the market will not recognize the cost to cure in a future sale or rental income. Also of the devil. Functional obsolescence, a loss in value due to changes in market standards or preferences resulting in an inadequacy or superadequacy in the structure. It may be curable or incurable. Highest and best use, the most profitable use of attractive land over the longest period of time. Historical cost, the actual cost of an improvement at the time of construction. Inadequacy is a deficiency in the structure that creates a loss in value. Indirect costs are costs such as permitting, engineering, architect's fees, and entrepreneurial profit, also called variable or soft costs. Physical deterioration, a loss in value due to physical wear and tear on improvements. Physical incurable long-lived depreciation, or PIL. Physical depreciation on the bone structure of the improvements. These are components such as framing, foundation, insulation, wiring, plumbing, pipes, etc. Physical lump sum method this method is used either the actual or effective age for the building and divides by the economic life to obtain a total of all estimated physical depreciation. Physical, curable, short-lived depreciation, items that have a life that is less than the remaining economic life of the improvements that are broken and need to be replaced immediately. Items that are broken, like water heaters, HVAC, repairs, or other items that are on the end of their usual life.
Their what kind of life?
Useful. Physical and curable short-lived depreciation, items that have a life that is less than the remaining economic life of the improvements that are not completely worn out or broken. Examples are roof with a 20-year life that is 5 years old, carpet with a 10-year life that is 8 years old. These items are depreciated on an age-life basis. What? You shouldn't have woken me up at 8 o'clock this morning. Quantity survey method, a method of cost that includes the count and cost of every board, nail, etc. to construct an improvement, rarely used in mass appraisal. Replacement cost new, the cost including all direct and indirect costs that would be incurred to construct an improvement having the same utility as the subject. Replacement cost eliminates all functional obsolescence from the subject in the cost estimation. Replacement cost new, the cost of constructing a replica of the subject improvements, including all functional obsolescence, using the same materials.
What did you call this one?
Reproduction cost new.
Okay.
Do you want to read this?
No. I didn't hear it that way.
Reproduction cost new is the cost of constructing a replica of the quit looking at me like that. The cost of constructing a replica of the subject improvements, including all functional obsolescence, using the same materials, construction standards, design, and quality of workmanship. Site improvements, improvements made to the land, not on the land, such as utilities, grading, sidewalks, curbs, and gutters. Superadequacy. A property that has an excess or greater quality not recognized by the market. Excess insulation is an example. Trended historical cost, the historical cost of an improvement that is adjusted using an index to reflect today's cost, including inflation. This is a form of replacement cost new. Unit in place method, a cost method that estimates value on specific components such as walls, foundation, roof on a per unit basis, and these values may be summed to estimate the total value of the improvement. This method is more accurate than the comparative unit method, particularly when materials of significantly different quality are used in a single improvement. Unit in place is not suitable for mass appraisal. Variable costs. All other costs associated with the project, also called indirect or soft costs. Highest and best use. That use which will produce the highest return to the land over a given period of time. Test of highest and best use, HBU, must be physically possible, legally permissible, financially feasible, and maximally productive. What is maximally? Land must be valued as is vacant and available for development to HBU. If the improvements are consistent with the HBU, the appraiser will value the property as improved. If the improvements are not consistent with the HBU, the appraiser must test to determine value. Estimate the value of the property with the current improvements and assume continuation in existing use. Estimate the value of the property as vacant, subtracting the cost to remove the current improvements. If the current improvements can be modified to the HBU, estimate the value of the property as if modified, subtracting the cost to convert the current improvements. The test above that produces the highest value is the highest and best use. Special use valuations such as ag, timber, park, and airport access land ignore HBU as instructed by the tax code and are appraised by the income approach. Land value estimate. Land is appraised by market approach or income approach. Comparable sales approach. Select sales of comparable property, list sales and subject properties, adjust sales to the subject property, and estimate subject property land value based on adjusted value of comparable properties. Alternative market approaches for land valuation. Allocation by abstraction. Property value less improvement value equals land value. Sale price of property less RC&LD equals land value. Allocation by ratio. Property value times land divided by property ratio equals land value. Direct capitalization. Ground rent divided by rate equals value. Land residual technique. Land income divided by discount multiplied by return on rate. Improvement valuation. Estimate cost using one of the four methods below. Replacement cost new less depreciation. The cost including all direct and indirect costs that would be incurred to construct an improvement having the same utility as the subject. Replacement cost eliminates all functional obsolescence from the subject and the cost estimation. Methods include unit in place, comparative unit, and market-based cost. Comparative unit is the most common used in mass appraisal. Sources for replacement cost. Published cost manuals such as Marshall and Valuation Service and RSM Eanes may be used for initial cost data. This cost should be adjusted to the local market by using the market-based cost estimate below. Example, 2,000 square foot building times $75.50 per square foot equals $151,000. Depreciation from all sources, 35%, which is 65% good. So the $151,000 times 0.65 is equal to the estimated value of $98,150. Market-based cost estimate. The goal is to find the estimate of the replacement cost due of improvements using sales. It is necessary to use current sales in areas that have sufficient land sales to estimate accurate land values. Property should have been inspected recently to correctly estimate depreciation. Market comparisons to estimate the contributory value of additives. Improvements that are not part of the improvement schedule need to be accurate. Assuming that all this information is available, this is the best method to check national cost schedules against the local market. Example. Sale price of improved property, $100,000. Sale date, December 30th, 2017. 80% good. It's got $7,500 of additives as of 1/1/18. It's got $20,000 of land value as of 1/1/18, and it's got 1,500 square feet of living area. So the solution is the $100,000 sale price times 1, because there's no time adjustment, equals the $100,000. Subtract the $20,000 land value. What?
Wait. Read across this way.
Seriously?
Yeah.
So do you want me to start over?
No, just start over in this section, yes, but read across.
I'm protesting. Sale price $100,000, time adjustment none, times 1, time adjusted sale price $100,000, subtract land value $20,000, subtract additive value $7,500, RCNLD $72,500, divided by percent good 0.80, RCN $90,625, divided by square foot 1,500, RCN PSF $60.42.
Yeah, per square foot.
Reproduction cost new less depreciation. The cost of constructing a replica of the subject improvements, including all functional obsolescence, using the same materials, construction standards, design, and quality of workmanship. The calculation is the same as replacement cost new, except reproduction cost is not replacement cost. Historical cost, the actual cost of an improvement at the time of construction. Trended historical cost, the historical cost of improvement that is adjusted using an index to reflect today's cost, including inflation. Appraisers use known cost indexes such as Marshall and Swift, Turner Construction, and ENRBCI. Trended historical cost is a form of replacement cost new. Example, a frame home cost $16,000 when it was constructed in 1970. What would be the cost of this same home to be today? Current year cost index 3152.7. Historical cost index 1970 is a 470.6, equals 6.6993 multiplier. Historical cost 16,000 times 6.6993 multiplier equals 107,189. Trended historical cost, or the cost today to reproduce the same home. Depreciation or percent good needs to be applied to the property to reflect RCNLD. If the house had an effective age of 30 years and an economic life of 50 years, the improvements would be 60% depreciated. 30 divided by 50 equals 60, or 40% good. The reproduction cost less depreciation of the house today would be 107,189 RCN times 0.40 equals 42,879 RCNLD. Depreciation, physical depreciation, a loss in value due to physical wear and tear on improvements. Physical curable short-lived, part of the breakdown method of the cost approach, items that have a life that is less than the remaining economic life of the improvements that are broken and need to be replaced immediately. Items that are broken like water heaters, HVAC, repairs, or other items that are at the end of their useful life. Physical and curable short-lived, part of the breakdown method of the cost approach, items that have a life that is less than the remaining economic life of the improvements that are not completely worn out or broken. Examples, a roof with a 20-year life that is 5 years old, carpet with a 10-year life that is 8 years old. These items are depreciated on an aged life basis. Physical and curable long-lived. Physical depreciation on the bone structure of the improvements. These are components such as framing, foundation, insulation, wiring, and plumbing pipes, etc. They're repeating themselves.
Yeah, because they want you to know it.
Am I reading this?
Yeah, it's not really hard.
Well, how do you want it read?
Well,
Functional obsolescence that is economically feasible to cure. Outdated kitchens and bathrooms may be curable. Functional incurable, functional obsolescence that is not economically feasible to cure. Ceilings that are very low or too high, poorly arranged floor plans, or excessive wall thickness. Direct sales comparison may be made between properties that have an item of incurable functional obsolescence with similar properties that do not have the same defect. The difference in the sale price tells us the loss in value due to incurable functional obsolescence. For example, sale 1 is similar to the subject except it does not have functional obsolescence. Sale 2 has the same functional obsolescence as the subject. Sale 1, 125,000 SP. Sale 2, 112,000 SP. Difference 13,000. Adjustment for functional obsolescence. Another method is to capitalize the rent loss for properties with diminished utility against properties that do not have incurable functional obsolescence as demonstrated in external obsolescence. External obsolescence is loss of value to an improvement due to sources outside the subject property line. The loss is applied to the improvement, not to the land. Examples: traffic congestion, water treatment plant, downwind of cattle feed lot, etc., always considered incurable. Example: properties without external obsolescence. Sale number 1, monthly rent $860, sale price $94,600, GRM monthly $110. Sale number 2, monthly rent $880, sale price $96,800, GRM monthly $110. Sale number 3, monthly rent $870, sale price $95,700, GRM monthly $110. Typical rent $870, subject property rent $710, rent difference $160 times $110 GRM equals $17,600 loss to the property. Land to building ratio 1:4 times 0.75 loss to the building equals $13,200 value loss to the building.
I guess they want us to figure out.
Practice questions are next.
Yeah, but I don't know why they want us to figure that out. I gotta figure out why they want us to figure it out.
Name an example of each type of depreciation and how to measure. Physical curable short-lived, broken window, cost to cure. Physical incurable short-lived, 5-year-old carpet, age, life with 10-year life. Physical incurable long-lived, building bone structure, age, life. Functional curable 1920 kitchen, replacement cost. Functional incurable floor plan, rent loss, sale. External incurable traffic noise, rent loss, sale. Using the 4-3-2-1 rule, what percentage of a property's value is in the first half of the depth of the tract of land? 40 plus 30 equals 70. What is the estimated value of the subject lot described in the chart below? 19,000. Sale 3, 29,000. Sale 1, 25,000. $4,000 adjustment for slope. Sale 1, sale price $25,000. Sale 2, sale price $15,000. Sale 3, $29,000. Sale price. Sale 4, sale price $22,000. Sale 1, date of sale current. Sale 2, date of sale current. Sale 3, date of sale current. Sale 4, date of sale current. Sale 1, size in square foot is 10,000. Sale 2, size in square foot is 7,500. Sale 3, size of square foot is 10,000. Sale 4, Size in square foot is 10,000. The subject was 7,500. Sale 1, the location is inside. Sale 2, the location is corner. Sale 3, the location is inside. Sale 4, the location is corner. The subject was corner. Sale 1, the topography is sloping. Sale 2, the topography is sloping. Sale 3, the topography is level. Sale 4, the topography is sloping and the subject is level. Sale 1, the number of adjustments is 3. Sale 2, the number of adjustments is 1. Sale 3, the number of adjustments is 2. Sale 4, the number of adjustments is 2. Sale 2, net adjustments plus 4,000, indicated sale 19,000 on sale 2.
I was just gonna say only sale 2 was worked out because it had the least number of adjustments.
I don't know.
I'm telling you. Sale 2 was worked out because it has the least number of adjustments and is most like the subject.
Okay.
So in other words, it's not necessary to go through and work all the comps. If you have one that has the least, work the one with the least number of adjustments. It's a shortcut.
You need to know that, not me.
That's why I said it.
You are appraising a vacant lot in a built-up neighborhood. A comparable lot with a 3-bedroom, 2-bath house on it recently sold for $88,000. You estimate that RCN for the house is $65,000. The improvement's depreciation is $20,000. What is the indicated value of the subject lot? $43,000. $65,000 RCN, $88,000 sale, $20,000 depreciation, $45,000 RCN LD, $45,000 RCN LD, $43,000 land.
Do you realize these are math problems that work down?
No, I don't. I don't have any idea. I'm just reading across.
Have you turned your brain off?